So hello guys, welcome in part number 3 of the design of one way slab. I'm really very sorry I'm making the 4 parts actually. I'm going to make the 4 parts because this numeric is really very lengthy and somewhat for the sake of reason I wanted to make in 4 parts. Okay, because it is not in consistent manner, so that's why. Please try to understand. Okay, I'm not going to make any sort of the changes because if you make in a 4 parts, it is liable for me to make a properly video. Okay, so now without wasting more time, please subscribe my channel and like my video. Okay, so now next step, as I told you in part number 2, that I'm going to design. I'm going to check. Okay, check for share. Okay, so how to check for share? Main thing is that, okay, check for share, that means you have to use as 456. Okay, main thing is that without as 456 cannot go for the this process, but I'll tell you what is the process exactly. First you have to determine VU. The formula for VU is WU into LE divided by 2. Okay, so formula, we all know all this value. So value are 9.38 multiplied by 3.111 divided by 2, so we get the value is as 14.6 kilonewton, or 14.6 into 10 raised to power 3, 14.3 into 10 raised to power 3 Newton. Okay, this value we got. Now next value is like this. So we have TV, okay, tau v, which we can call as, so VU upon B into effective depth. Okay, so value is like what we get, like right now 4. Sorry, we get 4.6, I write, or 4.3. 4.6 multiplied by 10 raised to power 3 divided by what is B, we have 100,000 multiplied by 111. Okay, so value we get is as 0.13. Okay, and this is a Newton per mm square. So guys, main thing is that you have to check the tau c is 0.13, but it always be less than 0.28 Newton per mm square. If this condition satisfied, okay, if this condition going to satisfied, then and only then you can say that this is what safe. Okay, so we are safe in also share also. Okay, so that's why we are going to for a check for deflection. We are going to check for deflection. So first of all, we have to determine the modification factor. Okay, we have to determine the modification factor, MF we call as. Okay, so first of all, we can we can calculate AST. Okay, AST required. Okay, so it is like this, that AST of main steel, AST of main steel, okay, is equals to 300.2 mm square. We know that. Okay, so what the AST we provided, we have to calculate. First, now we have to calculate the AST. What we AST provided, we have to here we have to calculate first. Okay, so we calculate in such a manner that what the spacing over here we have to provide it. So we know the spacing. The formula is pi diameter square multiplied by 1000 divided by 4 into AST. Okay, so now we know the for main steel we provided a 160 steel, 160 mm. Okay, 160 mm steel, pi into what is diameter, 8 mm square diameter we use for a main steel, multiplied by 1000. Okay, divided by 4 into AST. We have to AST provided, we have to calculate that how much AST we had to provide. Okay, so we get the AST provided as, okay, is equals to, we got 314.16 mm square. Okay, so after that we have to determine the FS. Okay, Fs is calculated by 0.58 multiplied by Fy. Okay, multiply by Fy, multiply by what AST required, upon what AST provided. Okay, so the formula we have to put the 0.58. Fy we have is a 415. Okay, Fy is what, 415 multiply by what the AST you have right now, that AST required 300.2, and what we provided is a 314. Okay, there is a changes, you can see. So FS we got is what, 230 Newton per mm square. Okay, after that, what the PT, percentage of limiting? Okay, per PT we have to determine it is 100. What is AST provided? Okay, we have to determine what is the percentage of AST we provided into B into D. So we get it is 100 multiplied by AST provided is was 314.16 divided by what is B is 1000 multiplied by 111, so we get 0.28 percentage of the steel we are provided of all the steel. From this we can determine how much amount of the percentage of steel we can determine. So we are going to provide 0.28 amount of percentage of steel. Okay, so from that there is a one table. From with respect to this we can simply determine the modification factor as a 1.7. I'll tell you the when one video on modification factor basically. Okay, you can take the from as code. There is one page, one table. From that the PT limiting to the modification factor, I'll just brief in my description box which table it is for modification factor. All I make one extra video for that. Okay, so from that just compare for 28% the modification factor given or there. If it is not given, you have to make interpolation simply. Okay, now this is what about the first we have that means for a modification factor you have to do the first thing. Okay, now the next thing is that this is what A, this is one value of the modification factor. Okay, then also you have to determine the L by D value. Okay, so with the L by that means for a deflection you have to first check the modification factor. After checking the modification factor you have to check L by D ratio. So first L by D ratio for the actual and permissible. So L by D is the actual, okay, this value, and second one is a L by D of the permissible. Okay, these two value you have to calculate. So it is what 3230 divided by, okay, divided by 111. So you get the 29.1, and the permissible is what 20 multiplied by modification factor. Okay, so you get it as a 34. Okay, so always the L by D actual is always less than L by D permissible. Okay, L by D actual is always less than the L by D permissible. Okay, then and only then your the depth. Okay, that means the check for the deflection is safe in a shear. Okay, in shear. Okay, now after that we are go for a check for a development length. Check for development length is really very important. I take the different color. Okay, so check, I think it is not visible properly. Check for development length. Okay, so check for development length is really very important. Okay, the formula, the steps I am going to discuss with you is like this. The LD equals to, the value formula is given in IS code 0.87. okay, Fy phi upon 4 into tau of BD, tau of B into D. So it is all when I put all over I get the value 376.1 mm. Okay, now second one is you have to determine the M1, which is a mu by 2, mu limiting by 2. So we get the value is at 5.675 divided by to the power 6 Newton into mm. Okay, then third one is the VU. Okay, VU is nothing but a formula W multiplied by LE by 2. Okay, so we get the value as a 14.59 Newton kilonewton. Okay, kilonewton into meter. Then fourth is what LO is nothing but all these value given in a formula given in a hash code. Don't worry about this, I'll just explain you what exactly all these things. Okay, so it is 230 by 2 minus of 25. Okay, so we get the value as 90 mm. Okay, then fifth is as 1.3 m1 upon VU plus LO. Okay, so we get the value as 595.65. Okay, so here if the L by D, the relation is L by D is greater than or not equals to 1.3 m1 v1. Okay, this relation given in I squared plus LO. Okay, if this well, that's L by D is what, 376.1 mm, and what is your 3.1 mm, which is 595. If it's not greater than and not equals to, if that means this relation not 3, it is 376.1, and this is what 595.65. So this relation is not, this relation is going to happen. So yes, okay, always this relation happens, then your development lane is also same. Okay, so after that, in this video I'm going to conclude that this is all the last calculation of the development lane is the last calculation. Okay, in next video, that means part number 4, I'm going to discuss with you that what is the reinforcement of the 8 we are solve in the numerical. Okay, so thank you and keep watching, keep learning my video, and have a nice day. Bye bye.